Hello, LASC. We are Gravity. We are from?
Bolivia.
Bolivia.
Hello, we are Gravity Team 41, a Bolivia competition in Latin American Space Challenge. This is the team, and my partner say that the next one.
Okay, we are Gravity Team 41, a rocket team from La Paz, Bolivia, competing in the Latin American Space Challenge, LASC 2026, in Brazil. From the past 4 years, we have promoted STEAM education and science outreach through workshops, demonstration, and education activities. Over the last 2 years, we have focused on develop a solid propulsion system, working on the design, testing, and validation of experimental rockets.
To develop the project, we divided our work in five main areas. These areas are rocket structure, recovery system, electronics, flight simulation, and analysis using Rocket Pi and Open Rockets.
Our mission architecture is built on three core pillars, as shown in the image. First, the rocket structure and airframe are optimized for structural integrity during high acceleration phases. Second, our recovery system is designed for a reliable descent. Finally, we integrate robust electronics and advanced flight simulation to ensure mission success throughout the flight envelope.
Okay, and our current rocket is approximately 1.5 meters long, has a diameter approximately 80 millimeters, and maybe is 1,002 grams. In this case, a part of propulsion developed, we have conducted experimental tests, for example, in this video. A part of propulsion development, we have conducted experimental tests related to solid propellant based on potassium nitrate and sugar, as well as static fire tests to evaluate motor performance.
Safety is very important for Gravity. All team members use personal protective equipment during technical activities. We identify and evaluate risks before each operation.
The test stand is a structure designed to measure the thrust of solid rocket motors before flight. It uses a 100 kilogram load cell connected to an ESP32 based data acquisition system to record the complete thrust curve. The design supports both horizontal and vertical testing configuration and can be adjusted to accommodate different motor sizes.
Especially on internal core of the mission, in this detailed visual workflow, we highlight our customized electronics base. Rather than use components, you're looking at the integrated mechanical housing designed to secure our flight computer and communication systems. You can see the precise relationship between the physical components and the design decisions we made to ensure sensor reliability throughout the ascent. To translate this integrated design into predictable flight success, we prioritize the simulation workflow you see here. By focusing on the flight dynamics and trajectory plot within the main visualization, we show how we use the data from the airframe and electronics model to building high-fidelity simulation. These results confirm our aerodynamics and structural predictions before the arc rocket ever moves to the launch pad.
Transportation. The team plans of the Department of La Paz now August 25 and the travel to the Latin American Space Challenge LASC in La Canga, Sao Paulo State, Brazil, using the ground transportation only. This travel method was selected for logistical and budgetary reasons, while also facilitating the safe transport of the rocket components, tools, and technical equipment. Rocket components include the airframe, fines, electronics, tools, and super equipment will be transport reinforced boxes clearly labeled experiment equipped fragile. All project-related materials will be transported in the accordance with applicable regulations and the compensation safety requirements. Transportation. The team plans of the Department of La Paz now August 25 and the travel to the Latin American Space Challenge LASC in La Canga, Sao Paulo State, Brazil, using the ground transportation only. This travel method was selected for logistical and budgetary reasons, while also facilitating the safe transport of the rocket components, tools, and technical equipment. Rocket components include the airframe, fines, electronics, tools, and super equipment will be transport reinforced boxes clearly labeled experiment equipped fragile. All project-related materials will be transported in the accordance with applicable regulations and the compensation safety requirements.
Prueba 2 con tobera. 3, 2.